Systems and series. Today we are diving into batch versus streaming processing. These are two distinct approaches to processing data, each with its own strength and ideal use cases. Understanding the differences between these approaches is key to designing systems that can handle data efficiently, effectively, whether you need real-time insights or periodic summaries. And you will use it. I guess it's a key thing when it comes to system design. I would say it's a quite important topic. It's not the most important, but it's one of the important topics. Okay, let's start first with the patch processing. Okay, so let's just go here and let's add text. So in the patch processing, batch processing is about processing large volumes of data at once, usually at scheduled intervals. With batch processing, data is collected over periodic time and then processed together into one go. So let's just try to get an example so we can understand what's going on here. So we have a client here, and this client, not a client, sorry, it's just an old habit. So let's say that we have chunks of data and a lot of them. Let's just say we have 1, 2, 3, 4. Let's just put all of them in one chunk here. So right now we have when data arrives, okay, when the data arrives here, this is data, and when the data arrives, in the batch processing, we'll just process them and stream them at once. So we have some sort of delayed output, and they will be delayed, some sort of delayed output, and they will be basically pushed. So how it works, the key characteristics of batch processing. The first thing, it's large data volumes. Like, batch processing is designed to handle massive data sets. Data is accumulated and processed in bulk, which is efficient for analyzing large quantities of information. The second thing, which is quite important to understand about batch, which is a schedule intervals. Like, batch jobs typically run at scheduled intervals, such as nightly, weekly, or monthly. This is useful for tasks that don't require real-time insights. The third thing is high latency, because since the data is quite big and all of them it's processed at once, there is a high latency. The results are only available after the entire page is processed, which means there is delayed in getting insights. The use cases in the batch process, I guess it's a great in the ETL jobs, like extract, transform, and load. So ETL, extract, transform, and load. Jobs are classic example of batch processing, where data from multiple sources is extracted, transformed, and loaded into data warehouses for analysis. The second thing, we have the data aggregations. Let's call it, yeah, aggregations, because batch processing is ideal for data aggregation tasks such as calculating sales reports or customer summaries, etc. Also, it's good in periodic backups. Backups are often done in patches where data is collected and packed up at regular intervals to ensure data integrity. The benefits of batch: the first thing, the efficiency to F. Efficiency. I guess if I type it, it will be more easier for me. So efficiency, because processing large data set in one can be more efficient, as operations can be optimized for the entire data set. The second thing, it's ideal for historical data. Like, batch processing is well suited for tasks that require analyzing historical data, such as generating businesses report and trend analysis. The drawbacks, I guess, there is a huge amount of latency. So there is not high latency, like enormous latency. um I would say results are only available after the entire patch is processed, making it unsuitable for real-time decision making. The second drawback is lack of real-time insights, because for scenarios requiring immediate insights, batch processing may not be sufficient because it has a huge amount of latency. So let's start to continue to talk about the streaming processing. Let's put it the middle. So in streaming process is about processing data in real time as it arrives instead of waiting for a patch. Stream processing allows you to handle data as soon as it's generated, providing immediate insights. Let's try to understand how it works. So basically, when the data arrives, like let's assume that when the data arrives, we have like basically we just stream them directly. Exact something like streamed. It is like streamed in the application directly, like we have some sort of instant output. Okay, so the key characteristics of streaming right now. First, we have real-time data handling, because stream processing handles data in real time, meaning that each piece of data is processed as soon as it arrives. The second, we have minimal latency, because stream processing offers minimal latency since data is processed within milliseconds or seconds, making it perfect for scenarios where immediate action is required. Third, there is continuous processing, because unlike batch processing, stream processing is continuous, with data being processed as it flows through the system. So the use cases for streaming, I guess it's real-time fraud detection. Like stream processing is ideal for real-time fraud detection in financial systems, for example. It's a great in live data feeds. It's a great as well in IoT applications, because IoT, it's Internet of Things applications, often generates a continuous stream of data from scenarios and devices, sensors and devices, not scenarios. Sorry. The benefits of this, we have low latency and we have a responsive system. The drawbacks of this one, we have some sort of complexity, because implementing streaming processing can be quite complex, as it's require handling data in real time and handling and dealing with the challenges like data consistency and fault tolerance. The second drawback is higher resource requirements, because stream processing often requires more resources to maintain the real-time processing pipeline and ensure data is processed with minimal delay. Okay, so let's try to answer the question: when to use what? So I would say use batch processing is ideal for scenarios where latency is not critical. It's not a critical concern, and you need to process large data set for reporting or analysis. It's perfect for historical analysis, data warehousing, and ETL jobs. You can use streaming processing is best for applications that require real-time insights and low latency, such as fraud detection, live data feeds, and IoT applications. It's the go-to solutions when immediate data processing required. So yeah, that's it for this video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss any video, and see you in future problems.